You might have noticed that security cameras and other security devices often warn of their presence by little red flashing lights. And I want you to imagine today that you've been hired by a company just to implement the logic for that particular electrical circuit. So we're not going to worry about the security camera, we're just going to worry about the flashing red light and the circuits and components and the logic in order to create that. For this project, we'll be using an online environment called Tinkercad. If you Google Tinkercad, it is the first result here. Now you should be able to sign up or sign in with your Google account. Once you've done that, if you click on Create and Circuit, because Tinkercad also lets you do other things, which we won't be doing, you will go to this view here. Now, just a brief introduction. We have this workspace on the left, and on the right-hand side, we have all of these electronic devices. We will be primarily using the Arduino, which is a small microcontroller chip on a computer board that can be used to write computer programs that control electronic devices. You can also drag on other things that you might need for your project, such as lights, resistors, and switches, etc. And you can, by left-clicking, wire up different components and connect them into electric circuits. You can also write code for the chip on the Arduino by clicking on the code button here. We will be using the text rather than the blocks, and the code will be written in a language called C++, which is fantastic for running very, very fast on low-powered, inexpensive chips like the Arduino. Your project should auto-save without you having to do anything. And if you want to change the name for what your saved file is, you can do so up here. So let's get started. In Tinkercad, I'm going to click on Create and a new circuit. And the first thing I'm going to do is change the name to Security Light, but you can call it whatever you like. And we're going to need some components. So the first thing we're going to need is our Arduino board, which we will program to do the flashing. So it's going to provide power in bursts, on, off to the light. The light is going to be an LED, which I will pull out here. And you can change the color, but I think red for my particular purposes is useful. So let's just learn a little bit about LEDs before we keep going. So LED stands for light emitting diode. Now a diode is by definition something that electricity can only pass through in one direction. So let's just get the 5 volts out of here and let's hook it up to the short straight pin here, and let's take the other side and hook it up to ground. Now if we hit start simulation, you'll notice that the light doesn't turn on, and that's because the positive, or the 5 volts, needs to be connected to the other side, which is this bent pin. So let's do it that way. And I have a feeling we're going to discover something else a little bit surprising about the LED. So we connect the 5 volts positive to the long bent edge here and the other side to ground. And let's click simulate. Now you'll notice here that it did work this time. However, the 5 volts was too much and it overwhelmed the LED and blew it up. And in real life, that would probably mean it flashes very bright for a second and then never works again, which is not ideal. And the problem is, if we think about these as being water pipes instead of electricity going through here, if you have too much water flowing through, too much current, which is called the same in electric circuits, then it will overwhelm this LED. So how do we reduce the current? If it was actually a water pipe, what we might do is we might have a small narrow area that, like a bottleneck, that the water couldn't go through as fast. Maybe something like this, where the electricity is coming in and it has this narrow area it has to go through. Now, this resistance here is created in electricity by the use of something called a resistor. So we can go and get a resistor here, but we need to tell it how much resistance. If it resists too much, it will stop most of the current flowing through and we'll get a very dim light. So we only want a certain level of resistance. I'm not going to go into the details of what this is or how to work it out because that's quite complicated. But just know for LEDs connected to the 5 volt on the Arduino, if we go and select ohms, which is this symbol here without the K, and put in 220, then that's probably the right amount of resistance for us. And you might notice that actually changes the colored lines. Resistors, you can tell which are which by the pattern of colors on them. Okay, so I'm going to click onto this now and bring it down. It doesn't matter where in the electric circuit it goes. It will still, just like the water example, a narrowing anywhere will slow the current in the entire circuit. So let's click on this and I will put it here, and we can connect this to here and this to here. And now hopefully when we turn it on, the light goes on and doesn't blow up, which is a definite improvement. The next thing I would like to introduce to you is the breadboard. Now, this is not so much of a concern now using the simulator, but if you'd like to take your design and actually build it using a real Arduino kit, how do we actually connect all these wires together unless we want to solder them, which is not that convenient? Well, there's a thing called a breadboard, and if you haven't seen it before, I'm going to go through a bit of an explanation of how it works. Actually, let's just delete all of these wires here. Okay, so the basic idea of the breadboard is that you can put in, and you might like to go and get yourself a physical breadboard to have a look for this to make more sense, but all of these pins can actually be pushed down into these holes on the breadboard, and likewise the wires have pins on the end of them that can be pushed down into here. And so what you can do is you can, for example, take 5 volts here and connect it up to one of the pins. So imagine that you've pushed the wire down into the 5 volts and into this hole. Now, if we hover over here, you can see that underneath the holes, underneath the plastic, there's a metal strip that electrically connects all of these 5 holes together. So if I was then to take this here and put it in there, then this pin here would be connected to the wire underneath with the strip. Now that won't work because the 5 volts is connected to the short end here, which is not what we want. But if we click on here, we can click on the mirror component button up here and it will flip around, and now it is facing the correct direction. Now we need the cathode to be connected to the resistor, so I'm going to use the rotate tool, it doesn't matter which way, to connect this. Now if I wanted to connect this terminal to this terminal, again we can just make sure that they're lined up on the same line of the breadboard. And finally, if I wanted to connect this terminal with the ground, I can connect it to any of these four, because they're all connected to terminal 2 underneath. So I will take this and connect this to the ground. Now hopefully, and it works. Fantastic. Now, something that's not so important, but just so you know, the wires at the start that are where the positive charge comes from, the 5 volt, is sometimes those are denoted as red, and the ones going to ground are denoted, or the negative side is noted as black. You'll see that on the breadboard itself here. However, it doesn't really matter for our purposes that much. Okay, so the final part of our project here is that we need this light to be flashing on and off. Now, this 5-volt power here comes permanently all the time, so we don't want that. I'm going to select a green, which I often use for wires that are coming in with programmed electricity. That's probably completely the wrong term, but what I mean is electricity that can be shut on and off with the computer code. And we can use any of these numbered ports up here because all of these we can control using the coding in the chip. 0 and 1 are used for other things that can interfere, so I'm going to start with 2, and I'm just going to take the wire and we need to come down and connect here. Okay, now we're going to go into the code section. Now we're not going to use the blocks, we're going to use the text. And I'm going to zoom in as much as I possibly can on this text while we're writing it. Now I'm actually going to delete this and we're going to start from scratch because I just want to explain a little bit about how the code works. So there are two functions here, one called setup and one called loop. Now on the Arduino, the setup function will run when we start the program, so when we plug it in or click start simulation, etc. And the loop function will just happen repeatedly as fast as the computer chip can possibly run it. But we can pause it in the middle using the delay function, and we'll talk about that in a minute. So let's put some code between these brackets to see what we want to do. Now the first thing we want to do is we want to go into and tell it that the pin 2 is going to be an output pin. It is sending out electricity to the light. And the way that we do that is we say pin mode with a capital M, number 2, and output, all capitals. And the final thing we do is put a semicolon on the end of the line. This tells C++ that we are finished with that line, and if you forget that, the whole program will crash. I know it seems a bit weird, but that's just the way it is. Now, the second thing I want to do is that in the loop, I want to continuously turn the light on and off. So how we do that is we can say digital write, and we tell it which pin, and we're going to say low or high. Now this is really on or off, but we just have to use the correct word here. So let's say we want to turn the light on. So we'd say set it to high. So basically it means write to pin 2 that it is going on high mode, so that is on. Then the next thing we want to do is we want to wait some amount of time, so maybe a second or so we can use the delay function here. And we can say 1000 milliseconds. Now there are 1000 milliseconds in a second, so that would be a delay of 1 second. Then we could probably copy and paste this code down into here, and we can say we now want to write it to low, which will be off. And then we want another delay of 1000 milliseconds. And then this loop will instantly go back to the top and run this instruction. So it's very important that we have this second delay. If we don't, it will write it to low, turn it off, and then instantly turn it on to high, and so it won't actually, we won't be able to see it go off at all. So high, 1 second delay, low, 1 second delay. So let's test this code out. So if we click start simulation, and you'll see that it is turning on, waiting 1 second, and turning off. Okay, if you'd like to develop this project a little bit further, you could actually have more than one light, and you'll notice the example at the start of the program had 2 lights, and perhaps you could make that work in some sort of menacing pattern on your security device. Don't have to, it's just an idea. So if you wanted to, you could, for example, connect pin mode 3 over here to another light, and you could get another LED, flip it around, and put it on here. And then you could, I think you can just Control C, Control V to get another one of these here. And you could take this and connect it to ground. Now you'll notice there are only 2 ground pins, but one thing that you can do with the breadboard that's quite clever is if we connect the ground here to any of this row, you'll now see that the entire row here is connected. So this is all ground, and we can connect this one to ground, and we can connect this one to ground, etc., etc., etc. And this should allow you then you can program these two lights to flash in some sort of different pattern if you would like. Anyway, I hope you enjoyed the project, and I will see you in a future project.